questions. So again, we've got a system of equations with an unknown, and we want to know for what values of P we might get a unique solution. So if we set it up as a matrix equation and just try to work out what values for P that determinant is equal to 0. So -3 by -4 is 12, minus P squared times 1 is minus P squared, that has to equal 0. So if I get P equal to plus or minus 2 root 3, I'll either get infinite or no solutions. Okay, so for any other P value, I will get a unique solution. So that simply means then that P can be any value except for plus or minus 2 root 3, which is that E. All right, 20, very similar. Set up the matrix equation. I guess we could do our solving if we wanted to manually. We could look at ways, we could set up little sliders, put the two equations in and muck around with sliders to see exactly what it looks like. We might do that in class. But again, if I find that determinant equal to 0, I said discriminant before, determinant, we get m plus 7, m minus 3 equal to 0. So for m equal to -7 or 3, we will get non-unique solutions. So I want no solution specifically. So if I put m equal to -7, I get -3x minus 6y equal to 5, 4x plus 8y equal to -10. Rearrange, and you can see there the gradients are the same, but my y-intercepts are slightly different. So that's going to be parallel lines. Let's check m equal to 3. I'll get, well, if I multiply the top line by 2, I'm going to have identical equations. So if m is equal to 3, I'll get infinite solutions. If m is equal to -7, I will get no solution. So that's D again, I think, is it? Last one, again, we've got a couple of different variables here that we're going to have to work with. One will affect my y-intercept, one will affect the gradient. So again, if we set up our system of equations, I'll get a 12 plus 3, P equal to 0. So P equal to 4 gives me either gives me either no solution or infinite solution. So straight away, we can sort of see that if P is equal to -4, in fact, if you read the options, D and E have exactly the same conditions. P is -4 and Q is equal to -5, but two different outcomes. So that's the one we really need to investigate, okay? So if P is equal to -4, if I put that into my equation, there's my two equations there. All right, so I get 2x on 3 minus q on 3, and y is equal to 10 on 6 plus 4x on 6. So we are going to have infinite solutions if my y-intercepts are the same. So if -q on 3 is equal to 10 on 6, I will have identical lines, which means q is equal to -5. So if q is equal to -5, we will have infinite solutions. So what does that mean? Otherwise, if q doesn't equal -5, I'll have parallel lines, so I'll have no solution. All right, so if P is equal to -4, it's either infinite or none. And if Q doesn't equal -5, I get parallel lines, so I have none. So that's E. If Q does not equal -5, I just had to stop and check then. But I didn't realize we're looking for the false outcome. So if Q is equal to if Q doesn't equal -5, we'll actually get no solution. So this statement is wrong. Yeah, the D statement is wrong. Because we don't get more than one solution, we get no solutions. Okay, so read false. Which one was false, sir? Okay.